So in the final video for chapter 5, I want to go ahead and think about how can we connect everything that we've been talking about so far um, with regards to conformation in 3D space. In chapter 3, we introduced the idea of a Newman projection. Just last video, we talked about the idea of a Fisher projection. And we originally, way back in chapter 1, we're doing a lot of talk about just like a skeletal structure or like a zigzag. And what I want to do is go through and think about how do we interconvert those. If you have a zigzag, for example, can you go to Newman? And then if you have a Newman, can you go to a zigzag? And then same thing, can you convert a zigzag to a Fisher and a Fisher back to a zigzag? And if you're able to interconvert between all three of those, you can know a bunch of information about your structures, and that will be something you will need to know how to do. Now here's a document. This exact same document that I have up on my screen is in Moodle at the way bottom of our, like right below this video. We're going to go ahead and kind of walk through it. So our very first one is going to be converting between a zigzag and a Newman projection. And for these, we kind of need to really just figure out kind of our wedges and our dashes. So I have a generic Newman that are shown at the top left, where I have A, B, and C being the things connected to the very front carbon, and then in red, X, Y, and Z being associated with the three groups that are attached to the back carbon. Now, if I am looking directly along my axis, I see that this, and then so for a Newman projection, we're looking directly along a bond. To go from a Newman to a zigzag, what we're going to need to do is we're going to need to turn that by 90 degrees. And if I look at this structure and I'm going to turn this by 90 degrees, when I take that and I turn that, the things that are going to be on my right side are going to be coming out at me, and the things that are on the left side are going to be going into the screen. So I'm going to define everything on my right side as being a wedge, and then everything on my left side as being a dash. So the very first thing I'm going to do when I'm drawing that zigzag is drawing a horizontal line, which is going to be the bond between my front carbon and my back carbon. Here, in this case, I see that A is going to go above me, so I'm going to do a vertical line that's kind of sloping towards me as A, and then a vertical line sloping away from me being X. And then I have wedges and dashes at my front and my back carbon, and the stuff that's going to be on my right, which is going to be my B and my X, are going to be my wedges, and then my C and Z, which are going to be my things on my left, are going to be my dashes. And there's going to be how we kind of convert from kind of a Newman to a Fisher, or sorry, a Newman to a zigzag. If you have a normal zigzag, you should be able to go to a Newman, hopefully pretty easily, because we learned that previously in chapter 3. Now, if we wanted to go from continue on. So if we want to go, like, for example, from a Newman all the way to a Fisher, we have to do one slight change in our zigzag. In our zigzag form, we don't have the proper backbone. So in a Fisher projection, all your wedges and dashes need to be coming directly out at you. And in this case, X and, if we view from the top, that is, so X and Z are coming out at us, but C and B would be like going away from us. So when we're doing a conversion of a zigzag into a Fisher projection, one of the things we need to do is we need to take and we need to rotate it. So here I'm going to go ahead and freeze my X, my Z, and my Y. But on my ABC, which I've called that original front carbon, I'm going to take that and I'm going to rotate that all the way around. And I'm going to rotate that so we get into a ellipsed-like structure. And here I now have my B and C on the top side, and then A going down. In a Fisher projection, unlike a Newman where we're looking directly along like your front carbon, back carbon bond, we're going to be looking from the top. And now if you see my eyeball up at the top, both X and Z and C and B are all going to be kind of coming up, trying to hug the eye, and A and Y are going to be going away from us. The only thing you need to really figure out is what's going to be at the top and what's going to be at the bottom. And the way in which I kind of have my eyeball, I have my eyelashes at the like right side, so I've defined Y as kind of being at the top. If you look at the other way, that's totally fine. You'll still get the same stereochemistry and everything. So when I'm then converting from my kind of flipped zigzag down to my Fisher projection, Y was all the way at the top, and then A is all the way at the bottom, and both of those are going away from my eye, as we kind of have shown there. So we're going to put those on the vertical axis. There's going to be this kind of cross for each carbon, and we have our front carbon and our back carbon. So there's going to be two. Again, when we're thinking about our directions, when I'm looking directly from that on the top, things that are going to be coming out of the page are going to be on my right side, and then things going into the page are going to be on my left side. So my X and my C, which are my wedges, are going to be on the right, and then my Z and my B are going to be on the left side. And that now gives me kind of a full Fisher projection. And as one kind of like quick reminder for your Fisher projection, even though we show those as just normal lines, those are actually wedges and dashes associated with them. And there is our kind of process of kind of interconverting between these. And this, I hope, will kind of be like a nice little instruction sheet or a way to think about, if I give you a Newman projection, could you go, for example, all the way down to a Fisher? Or if I give you a Fisher projection, could you actually turn that all the way back into a Newman? And what you want to do is just do a bunch of these individual steps. And both of them are kind of thinking about the direction which you're viewing, a Fisher being directly from the top, and a Newman directly from the side. So we're kind of like covering all three axes as normal. You have your normal view, which you can call maybe like along like an x-axis. Your Newman might be along a y-axis, and then your Fisher might be along a z-axis. So all three of these are just going to be different ways in which we can look at a molecule in slightly a different way and learn a lot of kind of cool and interesting information. So with that, we'll go ahead and end the video, and I will see you in the next one.